This is Unit 7, Lesson 4, Congruent and Similar Figures, Day 2. Let's quickly review. If two figures are congruent, the corresponding angles are equal in measure, the corresponding sides are also equal in measure. If two figures are similar, the corresponding angles are equal in measure and the corresponding sides are proportional. All right, in the next examples, we're going to base on the notation given in each figure whether they are congruent, similar, or neither. If the pair are congruent, then we're going to write the congruence relationship using the congruent symbol. If they're similar, we're going to write the similarity relationship using the similar symbol. If they're neither one, we're going to write neither. Example 1. We can see we've got two triangles. You can see that they have three sets of corresponding angles that are equal in measure, and they have three sets of corresponding sides that are equal in measure. So if everything's equal, then we know that those are congruent. So we're going to write the congruent symbol, and then we're going to identify one of the triangles by name using its vertices in whatever order we want. But then when we write the second triangle, we've got to make sure that we match up this corresponding vertices with the order that we've written the first one. So in the first one I started with angle Q, so I've got to start with angle U in the second one because that is a corresponding angle that's got the same measure. Then I went to D, and D has two tick marks, so we got to find the one with two tick marks in the second triangle, which is E, and then M corresponds with A. Now, I could have written that in a different order. If we had written DQM, then we would have written EUA. Either of those answers and a few other rearrangements are correct as long as the vertices match up in the same spot. Example 2. Let's see. Well, we don't know enough information at this point, but we do see that we've got a 40 for angle A and a 40 for angle D, so that's a good start. What we need to do is figure out what those other two angle measures are. So if I add 40 and 68 and subtract from 180, I would get 72. And if I add 40 and 72 and subtract from 180, I would get 68. So now that I've got all the three angle measures indicated, you can see that in fact they are corresponding and equal in measure, so we know that these are going to be similar. So I'm going to put my similarity symbol, and then we're going to list A, B, C, and then I need to match up the vertices. And so you see angle A is 40, so angle D would come first, and then we've got B is 68, so V would come second, and then C corresponds with T. Example 3, we're going to do the same thing. 50 and 59 subtracted from 180, that gives us 71. In the other triangle, we've got 49. You can see even though we've got A and D matching at 50 degrees, the other two angles don't match up, so it's neither similar nor congruent. Example 4. All right, let's take a look. Well, we've got two separate rectangles. We can tell they're rectangles because of the markings. First off, they all have 4 right angles. So we know that the angles, corresponding angles of each are equal in measure. So that's great. So now we have to decide if the sides are equal in measure. And you can see that they're not. The corresponding sides, 4 and 8, are not equal in measure. So then we have to decide, well, are they proportional? So what's important is that we identify the corresponding sides of the two separate rectangles and put them in a proportion and then simplify. So that proportion is 1/2. Then we're going to take the other corresponding sides and put those in a proportion and simplify, and we get a different ratio. So if they're not the same ratio, it's not a proportional situation, and so they're not similar. Therefore, we have to write neither. In example 5, you can see we've got two parallelograms here, and they have corresponding angles that are equal in measure, 2 sets of 100, 2 sets of 80. So we've got to do the same thing with the sides. Let's see if they're proportional. So I'm going to make 9 over 12 into a fraction and simplify and get 3/4. When we do the same with the other set of sides, we also get 3/4. Therefore, we know that it's proportional, so it's a similarity situation. So I'm going to write down quadrilateral ABCD. We have to find the matching sides, and that will be KLMN. Now, don't assume that the second one is going to just go in alphabetical order. You need to really make sure that the angles match up with the original figure. All right, example 6 is a little harder to tell because they're not aligned in the same way. So the first thing I need to do is check out my angle situation, and I'm going to add up 90, 90, and 130 and subtract from 360, and I would get 50, and I do the same thing with the other one, and I get 130. So I know the angle situation is equal. So that's a good start, and now we need to look for the proportional situation. So identifying the proportions here is a little trickier, but I'm going to first start with the two angles that are in between, the two sides that are in between the right angles. So that's 24 and 12. So when I make my ratio of 24 over 12, I get 2 over 1. Now I've got to find another matching corresponding side, and so then we have, you can see that AD is in between the right angle and the 130-degree angle. That will correspond with TW. We don't have a measure there, so I can't do a ratio for those two, so that's not helpful. Another set of corresponding sides would be BC and PV, and we only have one measure there. So we don't have another ratio that will prove whether these are proportional or not. Therefore, we can't make any decisions about whether they're similar or not. So our answer for this one is neither. That's it.